Welcome to Math and Measurements Part 2. So we have two objectives for this video. Describe the uncertainty that exists in a measurement and round off numbers to the desired digit. So we're going to be taking a closer look at significant figures here. So let's go ahead and jump right into it. So what is a measurement, right? So before we start talking about significant figures let me talk about why they're important. Now, when we talk about significant figures, uh, when you use them, you're used to using them in a calculation. So I say, do this problem and calculate the number of significant figures. But when do we really use them? Well, they're meant to be used when we actually do or take a measurement. So when you're in the lab, you have a graduated cylinder just like this. You're going to take the measurement, right? So you read it from the meniscus here. So when you take a measurement, there's going to be some sort of error to it. Why? Because you're taking the measurement. Okay, notice how the meniscus is not exactly on the mark here. It's a little bit under. So we know that this mark is 50, and this should be 51, 52, 53, right? So we know for sure it's 52, not quite 53. So we know it's somewhere in between. Now, how do we guess the next number? Right? So we're going to write 52, and the next digit has to be a guess. This is our error. That's as accurate as it's going to be, right? So we have two certain numbers is what we call them, and one uncertain number. All measurements have that uncertain number. There's always that uncertainty. Every measurement made with a device with a scaled marking, like this graduated cylinder, these are scaled markings here, has some degree of uncertainty. Even your scales that we use in the lab, the ones that measure mass, right? Those have some degree of uncertainty. Remember, the final digit fluctuates up and down. That's telling you that there's some uncertainty there. Remember, the more scale markings, the more precise it is. So a rule of thumb, very important here. Right? When making a measurement with a device with markings, you must estimate one place past the smallest marking. Right? One place past the smallest marking here. So, in other words, the smallest marking on this graduated cylinder is 1 milliliter. So we have 51, 52, 53. So 52 is our number, right? And then we got to estimate one digit past that. 52.8 is what we decided. So that's uncertainty there, right? So here's another example. So what is the length of this line here? So again, this is in centimeters. Make sure to note that. So we have centimeters here. We definitely have 1 centimeter, 1.5 centimeters, right? So 1.1, 2, 3, 4, 5. So we definitely have 1.5, not quite 1.6, not quite, but somewhere in between. So we're going to guess, so we have to write our two certain numbers, 1.5, and then guess that to be 5 centimeters. So that's our answer. So this is our uncertain number there. That's the one that is guessed. So let's talk about significant figures. In a measurement, the last number is always uncertain. In a measurement, all uncertain numbers and the first uncertain number are called significant figures. So essentially, any number that is not 0 is a significant figure. And then zeros, when you see a 0, it just depends. So example, a measurement of 1.86 kilograms actually means 1.86 plus or minus 0.01. So this uncertain number here, plus or minus one of those, plus or minus one digit here. So rules for identifying significant figures. Non-zero numbers are significant. Captive zeros, sandwich zeros are significant, right? Any number that's not 0 and zeros in between numbers are significant. Trailing zeros are significant only if there's a decimal. Trailing zeros without a decimal, not significant, right? So remember, if there's a decimal, that's good. No decimal, they don't count. Leading zeros, never ever significant. They never ever count. even if there is a decimal. All right, so you got to memorize these rules. Make sure to know them. It can be tricky, but the more you practice, the better you'll get at it. So exact numbers that were not obtained through measurements, right? Numbers that are not obtained through measurements. So what does that mean? Exact numbers, so counting numbers. So there's an exact number of students in the class. The numbers that belong to formulas, 2 pi r. An inch equals 2.54 centimeters. 2.54 is an exact definition for an inch. So those are not counted as significant figures. So anytime you do a conversion, right? Anytime you do a conversion, your conversion factors don't count as significant figures, only the given number. All right, so there it is.